How's everybody doing? Good? Cool. Welcome to NorthStar Taps. Welcome to Astronomy on Tap night. This is Thursday. I know some people have walked in. You guys, you can pay attention. You don't have to. You can have beer, really, whatever you want to do. This is going to be really exciting. Tonight we're actually we're going to be talking about the inner solar system. Obviously, some faces have been here every single time. That's super awesome. And I think it's about time we bring it a little closer to home. Like, a lot closer. A lot closer to home. 2 minutes? Oh, you're fine. Cool. Well, I'm going to take this time to thank Lumberbeard for sponsoring tonight's event. Thank you, Lumberbeard. We have 3 taps from them on right now. We have the Scandinavian Funk, we have the Hazy Pale, and the Batch 2 IPA. Have at it. What am I drinking? I'm drinking the Hazy Pale. It is fantastic. Way to go. What's up, Eric? Hey. Rocky. What's up? Perfect timing. You ready? Yeah, we're gonna talk about some cool stuff. All right. So thank you, Lumberbeard. Thank you, Brent, for hosting our event. We got Channel 2 here. They're doing a little thing on us tonight. That's really exciting. Couldn't have picked a better subject. And I'm particularly excited about this one because planetary science is not my forte. So it's extra exciting for me because I always learn things, and that makes this all worth it. So the inner solar system. Let's get started on that. Does anybody here, you can raise your hand very, very low. Does anybody here not know what a solar system is? Duh. Of course you don't. Cool. So you've heard of solar panels. What do? They collect light from the sun. A solar system is a system that orbits around a host star, or in our case, our sun. So when we're talking about our solar system, for part 1, because as people who have been here before know, I always bite off way more than I can chew, and there's way more to talk about than I have time for, and I know your time is precious, and your attention spans, some are shorter than others. Speaking of some of you. So I just want to jump right into it. Let's talk about the first planet from the sun. What is it? Mercury? You sure? 100%? You're right. Yeah, you're right. Totally, Mercury. Mercury is named after the Roman god, Mercury. Okay? The messenger of the gods. This is going to come back in a second. He was a messenger of the gods. He was very, very fast in Roman tradition. He even had wings on his feet. That's how fast he was when he would carry messages. And why would you assign such a title to such a celestial body? Does anybody know? Why would you call it the messenger when you're a Roman and you're trying to name something? No? It's because Mercury moves really fast. Makes a lot of sense, doesn't it? Why does it move really fast? Because it's really close to the sun. You know, the sun's pulling on it super hard compared to something like Venus or us. You know, it's pulling super hard, so it's going to move really, really fast. And because it's actually close to the sun, it happens to be closer to the sun than we are, that means we have to be looking in the direction of the sun if we want to see it. Okay? It's not going to be midnight somewhere and you see Mercury in the sky. And the same could be said for Venus, but like we'll talk about a little bit later. So you're always going to see it just before sunrise or just after sunset. Okay? It has the most extreme elliptical orbit in our solar system, I believe, for planets, that is. But the furthest away that you'll see it from the sun in the sky is about, I think it's 28 degrees. 28 degrees, for practical purposes, that is about the width of 3 of your fists put together at arm's length. You hold that up you put the sun on one side of your hand, put your 3 fists, that's the furthest distance from the sun it will ever be. So it's going to be close to the sun as the sun goes down or it is setting. Okay? Mercury, messenger of the gods. Now, what's really cool about Mercury being closer to the sun is we've been looking at it for quite some time. Okay, you can see it. This guy, Giovanni Zuppi, in 1639, actually looked at it and resolved phases. Okay, phases of Mercury. Much like the moon has phases, you know, it goes through, you know, gibbous, half, crescent, things like that. Mercury actually does the same thing because it is closer to the sun. And I actually have a little chart to explain how that works. But think of the year here, 1639. What this discovery made, seeing the fact that there are phases on another heavenly body, it was just another check in the box for heliocentrism. The fact that the Earth goes around the sun, the planets go around the sun, because there are things closer to the sun than we are. Okay, so that was really good for that. I do have a little chart here that shows exactly how we would see it, okay? When you look at Mercury with the telescope, and in fact Venus too, you will resolve a crescent if you have very good seeing conditions. Okay, and I'll show that for you in a second. But as it's closer to us, obviously the sun is going to be shining this way, towards us. So the side that's not facing the sun, which is the side facing us, will be dark. And the illuminated side will be facing away from us. As it goes to the other side of the sun, say we're on this side of the sun, we see it go to the other side like that, we will see it closer to a sphere like that. Now, when you look up in the night sky, you see that stars twinkle. If you don't know, the reason stars twinkle is because of our atmosphere actually bending the light from the stars as they come down. If you were in outer space, stars would not twinkle, they would be precise points of light. Okay? Now, as we're looking through our atmosphere, it bends, it blurs things extremely, and when you're looking at something low on the horizon, things tend to flicker a lot more because we're looking through a lot more atmosphere. You're not looking straight up, which is where the clearest imaging would be. It's where most big telescopes do all their science in this area here. Because it's always low to the horizon, it's always going to be fuzzy. So this is your average picture you would take. This is what you would see with a telescope. Doesn't matter how big or how small. That's about as clear as you're ever going to get it. So you're not going to resolve much science from this. We got to send something there. Okay, and it took a long time for us to actually do that. So it is super fuzzy. It's quite small, actually. Mercury's pretty small. It's around the same size as our moon. It's about a third the size of our Earth. And it's really hot. If you wouldn't guess that, Mercury's really close to the sun. It's about a third the distance from the sun that we are. Okay, it's like in the 34 million, 36. I think it has a very elongated orbit, so it's actually the most extremes. I think I have the distances somewhere. But its average distance is like 38 million light years. For reference, we are 93 million light years from the sun, or not light years, 93 million miles. Light years, what am I crazy? Okay, I should know this. Okay. Being that close to the sun, it's really, really hot. And how hot is it is the question. Does anyone want to guess? Let's just do Fahrenheit. We're not going to do Kelvin or Celsius, we're going to do Fahrenheit. Any guess as to how hot the surface facing the sun of Mercury is? Anybody? Huh? 43 degrees? This is not Price is Right. Like, you can go over a little bit, you can still be close.
1,000 degrees.
1,000 degrees?
Yes.
That's good, it's close. It's about 800 degrees Fahrenheit. Okay? Really, really, really hot. Okay? And that's on the side facing the sun. On the side not facing the sun, it can drop well below zero. Mercury does not have an atmosphere. Okay? Earth has an atmosphere. An atmosphere made up of different things that actually trap heat from the sun. And it kind of like cycles it around and keeps the whole planet, for the most part, at the same temperature, as opposed to all these other planets out here. Okay? Before going too far, I've been talking to some people, and what I want to start doing more of is explaining the story behind some of these discoveries. Because to non-astronomers, to non-science enthusiasts, it can seem really abstract. It's hard to imagine that people come up with these ideas, they make these discoveries. How do they do it? You know? Does everybody know what radar is? Yeah? Cool. Well, you know what we did with radar besides looking for planes? We started shooting it at planets to figure out how far away they were. What a great idea. What a fantastic idea. You know, we couldn't figure it out. There was actually an experiment done in the 1800s where they actually tried to measure the transit of Mercury across the sun. They timed the transit of Mercury as it was passing in front of the sun, because again, it's closer to the sun. And they were going to use the time passing in front of the sun to basically create a new yardstick to measure the entire solar system. And it was a colossal fail. The reason it was a fail was because it was so blurry. When they actually measured it, they looked at it, the images they were getting were so blurry that they couldn't get that precise measurement. That's why we had to wait for Doppler radar to actually discover the true distance to Mercury and Venus and some of the other planets. Okay? And that was in 1965. But on top of that, they also wanted to measure how fast it was spinning. This is really important. So how long does it take for Earth to spin one time? 24 hours. That's a day, right? So like one spin, where we're looking at the same point at the sun, what's that period? For us, it's 24 hours. That's one spin. We call that one day. Okay? Most of the planets spin pretty good. Mercury actually has a very, very strange type of spin and orbit. When you would first look at the data and you have some understanding of physics, you would say that's probably unstable. Okay? So, now, for the one time I wish I did have a whiteboard for this one thing, I'm just going to start rattling some things off. So, around the period of a year for Mercury is about 88 days. 88 days. Ours is 365, Mercury is 88. It takes about 59 days for it to rotate once. Okay, so we orbit once in 24 hours, but we take 365 days to go around the sun. Mercury actually rotates, so it'll actually rotate 1.5 times, or is it the other way around? Sorry, 88, 58. So yeah, it'll rotate 1.5 times for every one time around the sun. There's the other way around. Do you know? I got confused. I really wanted to draw a picture for this. The short of it is that you have these 2 points in an orbit. It's called aphelion and perihelion, the furthest and closest distance that something can be in its orbit. You know, it's not in a perfect circle orbit around a star. Sometimes it's going further out, sometimes it's farther in. What happens actually is that the sun, will actually pull on the planet as it's going around. If it's not spinning in a proper ratio with the time it takes to go around its host star, the tidal forces or the gravitational forces from the sun will actually slow down the spin of a planet to make it stable. Okay, so most of the time you're going to have one spin. You're going to have so many spins that equal one year or one full rotation. And if you have more than that amount of spins and you come to a different place when you make the appropriate amount of spins, you'll actually become slowed down until you become tidally locked, because everything wants to be stable like that. So, but what was really interesting to astronomers is that this was what happened was it turned out to be a stable orbit, okay? Because when something goes around, the next time it's actually in the same place, it's made a full rotation around, but the opposite side, the perfect opposite side of Mercury is facing the same location. So imagine that, we go around the sun, and we come around to this time today, but we actually end up 1 year exactly, but we are, 12 hours different from it. We're half a day different because we're facing the sun at this point, is what it would be. It's very strange, but it's actually stable, and it has stayed stable. Okay? I'm going to move on to this part. That's here. I want to take a look at the inside of Mercury, because this is actually really important. And that is the core of Mercury is actually very, very large. It's an iron core, but it's about 2/3, or it takes up about 75%, roughly, if I remember correctly, of Mercury. As opposed to us, it's actually quite small. And this made a lot of sense, because as slow as it was spinning, it didn't make sense that it would have any type of magnetic field, okay, like Earth does. But when we went there, we actually sent a probe there, and we did measure a magnetic field. We were wondering where it came from. It's not spinning. Where did that come from? And it's the fact that the core is actually so massive. But it puzzled astronomers. Why is the core so massive? It doesn't make any sense whatsoever. So when we sent the messenger probe to investigate, we did measure that. We saw so many great things. I'm sorry, I misplaced a slide here. I wonder if I can. It's okay. We'll get to it later. Okay. The messenger probe was the first real probe we sent to Mercury, but I wanted to actually mention what it stands for, because NASA is so funny. So messenger probe. Remember who Mercury was? He was the messenger of the gods. I just realized this today, by the way. I'm really embarrassed that the messenger probe went to Mercury, the messenger of the gods. But they called it messenger because it's an acronym. It stood for Mercury, Surface, Space, Environment, Geochemistry, and Ranging. I think that's kind of stretching it to get that kind of acronym. But rock on, guys. Love NASA. Okay. Cool. So when we passed by, we saw lots of craters. Okay? Makes sense. Lots and lots of craters. You see all the craters here? Which one's the biggest one?
The yellow one.
The yellow one? I think you're right. the entire picture. I believe it's actually the largest crater in the solar system. This one is actually, how big is it? 1,600 kilometers across. Okay, it's huge. What could make such an impact? And what would that do? When we saw that, what did we come up with? Going back to Messenger, and going back to why is that core so big? A lot of astronomers actually believe that there was a massive impact that hit Mercury that basically tore apart most of the outer part of the planet. Okay, leaving it only with a massive core and a thinner mantle and a surface here, and it's actually covered with basically charcoal, of all things. The pictures we see of Mercury are really brightened up. It is very, very dark. They were surprised how dark it was when they got there, because it was basically black, covered in charcoal. Okay, super cool. But it is absolutely littered with craters. And pound for pound, Mercury actually has the most violent impacts. Okay, and you ask why? It's not very big. It doesn't have enough mass to draw something in so big, like Jupiter or something like that. And the reason is because it's so close to the sun. So when things actually make it that far where it's actually going to hit Mercury, it's cooking. It is cooking right along. So you can actually have a smaller, say an asteroid or something like that. It can be much, much smaller, but be moving so fast that it can have more energy than something that's much, much bigger than itself. Okay, it's kind of like a rifle. You can have something very, very tiny moving very fast that has way more power than something that's very heavy moving slow. Okay, you can do a lot more terminal shock here. It's amazing. Cool. Other surface features that you can see are what these are called rupees. These are cracks in the surface. So a lot of people actually believe that these cracks actually formed from as the planet cooled. It actually shrunk, and it caused these cracks to form, and we see those, okay? Also, because it has almost no atmosphere, any impacts or anything that happens on the surface actually gets kicked up, and the solar wind will actually blow it away. And we can actually see that, okay? We can actually measure the dust that's being blown away like a tail, like a comet, from planet Mercury. I think that's really, really cool. Definitely one of my favorite things about that. And then one last thing I wanted to say was, what is the last thing you would expect on a planet that's 800 degrees Fahrenheit? And that is water ice. We actually found water ice on Mercury, and it is frozen, sitting there. It's actually on the poles, the North and South Pole, deep in craters that never see the sun. You know, there's no atmosphere trapping any heat. It's actually very, very, very cold at the bottom of those holes. And it's amazing, as we'll continue to go on, you'll see we're finding more and more water in the solar system. It's amazing. I want to move on to Venus. I'm always nervous that I'm not going to have enough to say, but I do. Okay, cool. All right, so Venus, this is the god of love. This is also where women come from. And the more you learn about Venus, the more it really verifies that. So we're going to talk about the hell of the solar system. It is actually the third brightest thing in the sky. What's the first brightest thing in the sky? The sun. What's the second brightest? The moon. Yes, the moon. Yes, the second luminary. And the third is Venus. You can actually see it during the day sometimes. But again, it's close to the sun, just like Mercury is. So we're going to see it just before sunrise or just after sunset is when you're likely going to see it. But you can see it sometimes during the day because it is so stinking bright. Okay? Before I want to go too far, I just want to show you a little comparison. Mercury being on the far left, Venus, Earth, and Mars. That's just to show you a reference of size, the scale, the differences between these things. And that's where that slide went. I'm sorry. I was trying to be all dramatic about planetary impacts on Mercury. So that's a picture of Earth in 5 years. Totally joking. Okay. All right. So there's another cool thing about Venus, and that is that the orbit of Venus, as we orbit the sun, most of the planets orbit the sun about the same. But Venus actually has a tilted orbit. It's about 3 degrees tilted. So as it goes around the sun, if it's closer to the sun, if it's on the other side of the sun, we can actually still see it. it'll actually be above the sun because it's just tilted on its orbit. So we'll actually see it more than we'll see other things. It also creates these really weird transit patterns. So remember when I said Venus would transit, it would cross the sun once in a while, just like a lunar eclipse. The moon would go in front of the sun and actually fully eclipse the sun. These little planets will pass right in front. Venus actually takes up 1/10 of 1%, as opposed to the moon taking up most of it. So you don't see it when it happens unless you have proper vision and maybe a telescope. It's very, very tiny. That's actually what you would see right there. Really, really cool. But the cool thing about the transits of these, though, is that they come in these little packets where I think it's, 8-year cycles. So you'll actually have one transit, and then you'll have another transit 8 years later. And then you have to wait like 107 years or something for it to happen again. And then it'll happen 8 years after that. And you have to wait another 100 and some odd years. And then you can wait another 8 years after that. So none of us are going to see the next one. It's going to be a while. I think the last one was 2004 and 2012, putting the next one at December 10th, 2117. So sorry if you missed the last one. It sucks to be you. All right. Now when we look at Venus, I'm going to actually skip this. I'm going to skip that too. I'm missing another slide. That's okay. What I wanted to say was when you do look at Venus, it can be brighter sometimes and dimmer other times, and that's basically depending on how far away from us it is. If it's on the other side of the sun and we're over here, of course it's much further away, but when it's closer, it's closer. The funny thing about Venus, though, is that the farther away it is, the brighter it is in the sky. Okay, this is super cool. Because, for one, the clouds that make up the atmosphere of Venus are highly reflective. I mean, very reflective. It's basically white. And two, when it's on the other side of the sun, there's more of its surface being illuminated. Whereas when it's close to us and we see just a little sliver, it's incredibly bright. Okay? It's really, really cool. We've all heard of the Apollo program. America went to the moon. We landed there. Some people believe we didn't, but they're wrong. So when we were doing that, the Russians actually went to Venus. They went a couple times, failed pretty much every time, and finally they, 1967 or so, they sent a probe out there, and it actually gathered data as it was plummeting into the atmosphere, and that was it. A couple years later, they sent another probe, crash landed it, and it survived for 20 minutes? Yeah, about 20 minutes. And this was in 1970. It lasted about 20 minutes, sends it back some data, and then it melted. Okay? Because Venus is very, very hot. And we'll go into that here in just a second. And then finally they landed on 1982, and it lasted 2 hours and 7 minutes, and they were able to take 14 photos and transmit it before it was again melted, crushed, and destroyed. And that is the picture that they took. That is a composite of about 14 pictures. What you're seeing on the bottom there is actually the base of the spacecraft, and that little circle thing on the center left is actually the lens cover that they dropped to take that picture. So they took that and spent all that money, and that's the first picture we had of the surface of Venus, which actually gave us a lot of information, which is really interesting. All right, so Venus is the victim of, and I'm sure you've all heard of this, but Venus is the victim of what's called a runaway greenhouse effect. Nobody knows for sure exactly why it happened, but I think what most people believe, what is the most compelling is, a long time ago, when the sun was younger, it was actually not as hot, it was cooler, okay? And when it was cooler, some people believe that Venus was actually, inhabitable. It could have had water. It could have had all kinds of things. As the theory goes, that as the sun started to expand and age and heat up, it slowly started to heat the planet enough to boil away some water. And water is a fantastic insulator for heat from the sun, okay? And as it did that, it boiled more water away, trapping more heat from the sun, trapping more heat from the sun. It actually got so hot that the carbon dioxide that was actually dissolved in the water started evaporating. And then you have another greenhouse gas, which is carbon dioxide. So that's basically just, throwing gasoline on a fire. And it got so hot even then that the carbon dioxide was boiled out of the rocks. to the point where you basically have a super thick atmosphere of carbon dioxide and sulfur dioxide. It's really hot. We're talking about 880 degrees Fahrenheit, hot enough to melt lead on the surface. And we're talking about a surface pressure about 1,000 times more than Earth's surface pressure. So these probes, when they land there, they're literally melted and crushed by just the environment on Venus. It is the most uninhabitable place. But some people want to go there and build a space station, or build a base there. And the best thing is the whole idea is that it would be just like the Sky City in Star Wars Bespin. They wanted to build these cloud cities. There's legit things on this. It's actually really, really awesome. So when we actually, there's other ways to look through the atmosphere of Venus. There's something really strange that we see though, and that is a lack of something that most other places in the solar system have, and that is craters. Very strange. There are about 1,000 craters we've seen on the surface of Venus, which is a very small number. And they're super evenly distributed, and they all show erosion at basically the same rate, saying that they're all about the same age. So the only conclusion you can come to is that Venus had to have resurfaced itself. Earth does it. We have volcanoes. We have a new surface. It's going to cover things over. Something must have happened on Venus that resurfaced it. Nobody really knows what it is, why. Okay? We don't see any active volcanoes there now. There is evidence that back in the 70s there could have been a massive volcanic eruption, which we actually measured rising levels of certain gases that would confirm that, and that those levels actually went back down in the 80s when everything subsided eventually, cooled off. So, you know, there might be volcanoes there, but we don't know if it's geologically active in that way. Some people have actually said that the entire planet of Venus is one giant supervolcano, and that once every so many years, the whole thing erupts and resurfaces itself, which sounds like a pretty cool idea. And Venus is already really hot, so I played with a lot of lava in my life, because I'm from Hawaii, so go to the volcano and play with lava. You know, it cools off pretty quick. You can step on flowing lava and it will turn into rock. You know, because you and the lava want to be the same temperature when you touch, and your shoe will steam a little bit, but it will turn into rock. Venus is already almost 1,000 degrees, and it's going to keep that lava hot. So when lava is pumping out of the surface of that planet, it can spread out and stay hot. It doesn't harden. So you get these really cool features. These are called pancake. It's like pancake flood basalt. It's called pancake something. But basically, the lava will actually ooze up like that and spread out evenly. It's really, really thin because it's so hot. It creates these big pancakes. And each of those pancakes is about 1 kilometer tall. Okay? Super cool. And it can be, I think we've measured them out to 80 kilometers wide or so. Really, really interesting. This was another thing showing the phases of Venus. We'll go ahead and skip that. Now, Venus is really hot. What is the last thing you would expect to find there?
Water.
Water? Okay, I don't think there's much water there, but that's a good guess.
Walmart. Beer.
Beer. Walmart. It's definitely there. Yeah, it's on the far side. No, snow. Snow-topped mountains. Okay? Now, nobody knows exactly why, or if this is what it is, but most people tend to think that some of the minerals that are low-lying on Venus' surface under high pressure, high temperature will actually start to evaporate. We're talking minerals like metal, bismuthite. Which one is it? Bismuthite, and there's another mineral that's on there. It'll actually evaporate and cool off as it rises, and it will deposit as snow on mountaintops. So it literally snows metal on Venus. What a crazy place to be, right? Another cool thing about Venus is that it doesn't have much of a spin. You know, it basically doesn't spin at all. I have an orbital degree here, right? Maybe I don't. Okay. So it's actually, it's almost not spinning, but it's actually spinning backwards. Okay? So as we go around the sun, we're spinning around with the sun. Venus is the only planet that's actually spinning the other way as it's going around the sun. Very, very slowly. And nobody really knows why. But there is one good idea. What could cause a planet to almost slow down or even spin the other way? Can anybody guess what it is?
Planetary impact.
Yeah, that. Okay. Planetary impact, because it is spinning. Another thing comes in and smacks it and slows it down. And this could also have actually slowed it down so much that if it did have a magnetic field being generated by its spin, it would have instantly stopped, or it would have stopped basically. Therefore, it would have no electromagnetic field, no shielding from the sun, and it could just get hotter and hotter and hotter. It pretty much got the raw end of the stick. I mean, yeah, women are from here. They got the raw end of the stick for a long time. That really sucks. Okay. Anyway, and then one final thing, speaking about it, because there is a little bit of redemption here, and that is every surface feature on Venus is named after some woman sometime somewhere. There are no male names on Venus in homage to the goddess of love. Oh yeah, but it's also the origin of the term venereal disease. Venus venereal because it is the goddess of love and everything that comes with it. And so we move on to Mars. Okay, this is where men are from. A lot colder, a lot more boring. You know, all men want to go there and hang out with them. Okay. So Mars is about half the size of Earth. It's pretty small. It's further away. It's actually really cold. People used to think it was really hot because it was red, but it is not. It is quite cold. The reason it's red is because the surface of Mars is actually covered in iron oxide, also known as
Rust.
rust. That's why it's red. There are you'll see a lot of gray in there too, and that's actually the same type of basalt that our planet creates, like gray and black basalt that turns into sand. You see a lot of black sand beaches on young volcanic islands. Okay. Cool. This is really funny. So I'm not very old, but some people in here have been around since the 60s. And I don't know if you remember, but back in the 60s and 70s, a lot of people still thought that Mars could have been habitable. You know, people talked about something living on there being water. You know, a long time ago, a famous astronomer actually looked and plotted all of these straight lines on the surface of Mars and actually called them aqueducts. They thought that they were actually channeling, obviously we don't see them now because he had a really bad telescope, but he was thinking that it would actually channel water from the poles. As the poles would melt, it was a way that he thought a civilization would actually get water from one place to another. So his whole thing was that he found intelligent life through his telescope, and the joke was that he found intelligent life, but it was on the wrong side of the telescope. Okay, cool. So something really cool there's so many cool things about all these planets, but there's a real dichotomy between the northern and southern hemisphere of Mars. Okay, so this is basically a topographical map showing elevation, or altitude in this case. So there's a few cool things to point out, and that is that the southern hemisphere, I always get this mixed up, but okay, so the northern hemisphere up here is basically flat. It's basically just plains. Super flat, all plains. Whereas the northern hemisphere is super rocky, mountains, volcanoes, craters, super, super busy. A lot of things going on. There's a huge, huge difference here. It's actually so extreme. On the top there where it's all flooded down there, people actually thought that all was full of lava at one point. And the elevation is actually so much lower there than it is on the northern hemisphere that you could actually walk from the South Pole to the North Pole and never walk uphill. You would walk downhill the entire time. How cool is that? Yeah, that's how drastic of a change that could be. Okay? All right, so you see that big blue spot on the right side there? People were wondering what that could have been. Can anybody guess what that could have been?
An ocean.
How about another planetary impact? This is what a lot of people think that it was a massive impact on Mars. They measured it to be about 100 kilometers across. It happened a long, long time ago. And when that happened, it actually left behind that basin that I showed you completely full of lava. And it potentially actually could have resurfaced the planet on its own if it happened long enough ago. Okay. Totally cranking on time here. Yeah, let me get moving here. Let's move on to another really cool feature about it, and what everybody knows, obviously, so on the left side there, you'll see you have 3 volcanoes, and on the left there is the largest volcano being Olympus Mons. A lot of people know what Olympus Mons is. It is the largest volcano in the solar system. Here's another picture of it from space. It's cool, you can see the atmosphere. And it is so big, in fact, I have a chart here to compare it. Mount Everest being the shortest guy on there. Olympus Mons is much, 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 much bigger. But why are our mountains capable of being so much bigger on a place like Mars? Some people may have remembered from another talk I had here. Gravity pulls things in, right? Makes sense, okay? So when something's bigger, it has more gravity, right? So when something has less gravity, it doesn't pull as hard. When gravity's pulling in every direction, it naturally wants to make spheres. That's why you see spheres everywhere, okay? The cool thing about places like Mars is that they have a lot less mass than Earth. So there's a lot less mass actually pulling the surface, everything in. You can actually get larger mountains there. On Earth, you won't get as big of mountains because the planet is not pulling quite as hard, you'd say, on Mars here. I did want to talk about another piece here, which is the Tharsis Bulge, okay? And that's, I can't do that, can I? I can. So this was Olympus Mons here. This is called the Tharsis Bulge. You see how it's all red? It's very, very red. That's because this is actually bulging up, like a really massive bulge in Mars. A lot of people think it's because of all of the, and it's probably true, it's because of all the volcanic activity. It's actually building up pressure. We can actually see that on Earth too. So in Hawaii, you have the Mauna Loa volcano, which is the largest volcano in the world. And on the side of Mauna Loa is actually another volcano called Kilauea volcano. And growing up there and knowing a lot of geophysicists, we've actually measured that you can measure the elevation of Kilauea going up and Mauna Loa going down. And when Mauna Loa goes up, Kilauea goes down. Because the pressure is equalizing. The pressure from all of this lava will actually force the land up. And what also can happen when you force the land up so violently like that is right here. Okay? This is the Tharsis Basin. Okay? Now, this is going to be one of the most interesting things about Mars, because it is actually a giant canyon, the Tharsis Basin, and it is much bigger than the Grand Canyon. This is the Grand Canyon in Arizona here. This is Tharsis Basin, or Tharsis, the canyon here. So it's actually been measured now to be almost 4,000 kilometers long, whereas the Grand Canyon in Arizona is about 400 kilometers long. And it's actually wider than the width of the United States. It's also 8 kilometers deep as opposed to 1.6 kilometers deep in the Grand Canyon. So it's massive. It would be one of the most impressive things you would ever see if you were ever standing on the edge of it, looking straight down. It's absolutely amazing. So they really think that a hot spot, kind of like the hot spot in Hawaii in our tectonic plate, was responsible for that bulge too. I wanted to mention that. All right. What's also interesting is that that crack there, they say that it was formed from the bulge here, and it was not formed by water. Most canyons are actually formed by just water runoff, like the Grand Canyon, but this was not formed that way, which is another really interesting point. Okay. Another thing is the last thing you would expect on Mars is water, and that is basically snowy, cold water poles. The North and South Pole are covered in water ice. Okay, and it is seasonal between their summer and winter seasons. Depending on the respective hemisphere, you'll actually freeze the carbon dioxide in the atmosphere, and it will deposit as between 1 and 8 meter thick deposit of carbon dioxide or dry ice on the poles. And when it warms up again, that dry ice will actually evaporate, and the CO2 will go back into the atmosphere. When it does that, the winds rage incredibly violently. I mean, they can be, it's insane. I don't even know the actual number of how fast the storms can blow, but they can be so violent that it can cover the entire planet in storms, and it actually creates sand dunes, absolute sand dunes. Each of those dunes is a couple inches tall. This is taken from the Mars rover. It looks a lot more dramatic. So, who here has seen The Martian? Okay, cool. Remember the first scene when the wind comes in and blows the rocket over? So the whole premise of that movie is completely false because the atmosphere on Mars is so thin that even if the wind were blowing hundreds of miles an hour, you wouldn't even feel it at all. You know, it's enough to blow particles around. It's actually enough to make dust devils, small tornadoes, and leave behind these super cool patterns that we see. We've had the Mars Reconnaissance Orbiter has been orbiting so long that it sees all kinds of cool things like this happen on the surface. You know, we actually see, this is what Mars normally looks like. This is one of those storms that's happening. The entire surface is covered with blowing rust, and it creates those dunes. It's just amazing. What's another thing you would never expect? Let's try avalanches. There's straight up avalanches being recorded as they happen on Mars from our reconnaissance orbiter. That's insane. We're also seeing brand new impacts. Look at that, 4th of June 2008 to 10 August 2008. That is a new impact, and it has been verified, it has been confirmed that is a brand new impact from some type of near Mars object. And it hit, and it gets hit all the time. Very, very cool. We have been finding a lot more water. We're going to talk about that in a second. Mars has 2 moons, very different from our moons, Phobos and Deimos. Phobos, I believe, is what, about 30 kilometers across. Deimos, about 14, 15 kilometers across, so pretty small. So small, in fact, that they look closer to potatoes than they do to a softball. Remember when I was saying that you need all that mass to crush something into a sphere? These are so small, they just can't. They end up looking like potatoes. Phobos, actually, well, a lot of astronomers actually believe that these were not just moons, these were actually captured asteroids from the asteroid belt. Okay? It just came in at the right angle and they captured it and became a moon. That's what a lot of people believe. We don't know that for sure, but what we do know is that Phobos is orbiting very close to the surface of Mars. It's like 6,000 kilometers. Our moon is like 220,000 kilometers. Big difference. Of course, this is much smaller, but it's actually dropping too. It's lowering further and further and further, closer to the surface of Mars, and a few million years from now, it will actually impact Mars. And it's cooking, and it is very big. We're talking 30 kilometers across, so that's going to be really exciting to see, as long as we're not there. Okay? This is fairly new science. One of the new rovers went up there and dug a hole. And guess what happened? Ice started forming. Possibly subsurface water. Water just below the surface. We see Mars now, there's no oceans. There's evidence that there was oceans possibly at one time. Absolutely. Possibly life even. But we just, scratched a hole in the sand and ice started forming, indicating that this could be actually just subsurface ice and water. And that's not all, because we have more evidence. On the left is a brand new impact, and when it did, it kicked out all of that white stuff, which everybody, it's water. It's subsurface water. On the right side, that is ice that is formed from a water flow from the side of an impact crater. These are happening in real time, 1999 to 2005, that is brand new. That is super, super exciting. Awesome. So, really good chance that it had water, had life. We don't know. When we go there and we start digging holes and send people there, one person in 5 minutes can do more work than an orbiter can do in like 6 months. Or not an orbiter, but some type of rover. It's hard to communicate with those things like that. Humans are still awesome. Anyway, so those are the most exciting things I can think about Mars right now. There's definitely a lot more coming up. But before I'm running out of time here, I got a few minutes. There's one thing that happened very recently, and that was, not last week, but the week before Sunday. I believe that was on the 4th of February, something like that. We actually launched a new satellite. And this one is particularly exciting. It is called the Solar Orbiter, and I got a really cool artist rendition of what it's going to look like. This just shot off, and it's amazing what we've been able to do. Anybody ever heard of Teflon? Yeah, Teflon, good. So we're super excited about NASA creating these spin-offs that we use in everyday life, like Teflon or rumble strips on the highway that came from NASA. All these different things. Well, there's a new one coming out. So we watched the conference on this, the press conference before the launch. It was a great launch. But what they were talking about was this solar orbiter is going to go basically take new measurements and data from the sun. You know, we're trying to study stars, and we sometimes forget to realize that we have one right there, and we should probably go look at it, because we can't go to the other ones, right? So we're going to send a new one up there. Now, we had to design this to basically handle anything, because it's going to be really close to the sun. This satellite is going to undergo temperatures over 800 degrees Fahrenheit. Remember that that temperature can melt lead, basically, a little bit more. So you have to design these instruments to withstand that heat, okay? This thing's going to be facing the sun. This thing's going to be within the orbit of Mercury, okay? And it's going to be cooking. Now, a couple of things of note is on the front, where I was talking about spin-offs, there's a shield on the front of this satellite that protects all the instruments, and it has there's no moving parts whatsoever. It's just the material and the shape of it, and the way that it's implemented. It is the best way to siphon heat off of that material and shoot it out the side of the spacecraft. So it's going to, with no moving parts, just by the nature of the material, it's going to keep it cool enough for the cameras to stay cold enough to gather data. I think that's one of the coolest things. So we're going to see a future of new types of radiators, maybe, for cars that don't have moving parts. I don't know. We'll see. Come on, you engineer people. It's awesome. Another thing you see is it has to be powered, so it has these solar panels sticking out, but they're not facing the sun. Don't you want to face your solar panels to the sun? Of course you do, unless the sun is so hot that it's going to melt your solar panels. So we actually have to keep it at an angle. There's barely any bit of solar panel that's actually gathering energy from the sun because it's so absolutely intense. When it dips into the sun, it's going to take about 7 years to get to the point where we're going to get all the really good stuff. It's going to take 2 years to get there. We're going to get a gravitational slingshot off of Venus, I think twice, then shoot out towards the sun, hit this. We're going to get really, really close, similar to what we did with Jupiter. And we're actually going to take the first pictures of the north and south pole of the sun. How cool is that? Nobody's ever seen the poles of the sun before. What's it going to look like? Who knows? It's going to be exciting. Okay. This little boom arm here actually just got deployed. I read it today. It's successfully deployed, and on the end of this is actually 8 meters long, I believe, this boom, because they have these instruments on the end to measure the magnetic field of the sun with such precision that it has to be that far away because the magnetic field generated from the electricity in the wires is overwhelming to the instrument because they're going to map the magnetic field with such precision. And I'm so excited about this thing, if you can't tell. It's actually going to get into a locked orbit where it will observe the same surface of the sun for, I believe, 22 days or 28 days, all at one time. If we see things like sunspots or a solar storm, we'll actually see it evolve over time. We won't just take one picture after the fact. We will see it happen. We'll see everything. It's going to be amazing. What we'll learn from this will definitely inform further research in the future. I'm very, very, very excited about this one. It's going to be great. And the reason I wanted to bring it up was because most things we do in society now are very short term. The best thing about this field of astronomy and cosmology is that these projects take so long that it takes us investing our resources and our interest in it. The Pluto project took 10 years to get there after it launched. We're not going to see the great stuff until 7 years from now. So we got to stick through it. We don't just wait 2 years. So in 7 years, I just want everybody to remember, oh yeah, I remember we did launch that thing. And when we discover something new and exciting that changes the world forever, we're going to be like, man, that was awesome that we did that so long ago that in the moment, if you told me that it's going to take 7 years to get there, I'd say let's spend the money on something else. So let's get that out of our head and realize that this is really important. Some of the best things that bring us together are found in the field of astronomy. Any questions or anything else? I think I'm done. 4 minutes early. Yes. Does anyone have any questions about anything? Do you want to say something? Want to correct me?
Yeah. Not a correction, a question.
Sure.
So everything is a sphere except for those potatoes. Why the potatoes again?
Okay, so remember how I said gravity's pulling things in? Okay, so when you have a center of gravity here, the closer towards the middle of, say, a sphere, if everything's pulling towards the center, the closer towards the sphere, the more of that pulling power is. Okay, so the bigger something is and the more power it has to pull in every direction, it's naturally going to form a sphere, okay? But if something doesn't have enough mass to crush into a sphere, it'll still kind of come together because gravity works. You know, things can bump into each other and actually kind of slowly touch each other for billions of years, you know, and not have enough mass to actually combine into something where they're one thing now. You know, those moons are just small enough that they don't have enough mass to crush themselves into spheres. That's why. Yeah.
I actually have something to add into that.
Sure.
It's about a diameter of 1,000 kilometers. It's about the size for rock
Is that the
to
limit?
start to- yeah.
Okay, cool.
Yeah, it's bigger than that will start to form a sphere.
And then the bigger and bigger from there, the easier and quicker it can be. And,
Okay.
yeah, totally. Which actually reminded me, like Venus. So Venus is actually the most spherical planet, or the most spherical body in the entire solar system that we know about.
What
Wonder
about
why.
Jupiter?
Huh?
What about Jupiter?
No. Not even close. It's actually almost the exact same dimensions at its equator as it is on its poles. And the reason for that is because it's not spinning very fast, if at all. You know, it's very, very slow. You ever take a ball of pizza dough and spin it? What happens? It goes flat. That's why Earth, when it's spinning the way it does, the Earth is actually not a sphere. They call it an oblate spheroid. It's actually a little wider on the low, just below the equator. It's actually bulging out. Looks more like a pear. Exaggerated. But don't get me wrong. The Earth, if you made the Earth the size of a cue ball, the Earth would be more of a perfect sphere than a cue ball. I mean, that's how close that is. Another really cool fact. I'll shut up after this. But the surface of the Earth is actually so thin, and the oceans are so shallow and thin, that if you shrunk that down to like the size of a typical office globe, if you ran your finger across the surface, you wouldn't feel mountains. It would be perfectly smooth. The smoothest thing you've ever felt, actually. And the deepest part of the ocean is shallower than the depth of your fingerprint. That's how shallow that is. You wouldn't even be able to feel that it's wet. And then the ocean seems like this giant thing. It's actually basically nothing. It's amazing. Okay, before I start, just giving you more Snapple caps information. Anything else you can think of? What do you guys want to talk about next? We already know what we're going to talk about next, and that is going to be Jupiter, Saturn, probably Neptune and Uranus. We're going to talk about that next time, which are also equally interesting. You have no idea how interesting those things can be. So. But you're about to. Please come next time, and thank you for coming this time. Thank you, Lumberbeard. Thank you, Brandon. We're going to wrap some stuff away. Who wants to win something? Yeah? Cool, we got some swag. Let's give it away. Okay.
Hey, how's it going?
Does anybody not have a raffle ticket? Anybody? Cool, good. I'm just gonna say that I stole one. Yeah. Lumberbeard?
Is Maddie up there?
Your sticker is gracing my music stand. You got a new one.
Say hi to her.
You would like her a lot.
I'll tell you what. Who don't you like? Because I'm going to put it over the top of it. So we got Belgian Beaver, Piet, Kevin. We'll do that later. All right. Now, see the first raffle ticket. Here we go. We're giving away. Okay, we're going to give away a glass with a sticker. Here we go. There you go. All right. Priorities. Here we go. Raffle ticket ending in the numbers 973. Yay! Woo! Johnny Bravo wins it. You get a paper bag. One empty bag with one pair of socks. All right, here we go. Man, we got a lot of stuff to give away. This is awesome. I feel like Oprah. You get a glass. You get a glass. You get a whale. You get a Kia. How about 963? Who's got 963?
That's you.
What's up, Eric? Rock and roll. Raffle ticket ending in the number 961.
Ow!
Nice.